Corneal biomechanics are very important to the clinician in a number of different applications. Really, the first and most important is the detection of keratoconus, especially subclinical keratoconus prior to refractive surgery. In addition, biomechanics are very important in IOP measurement error, since they have a much greater impact on error in applanation tonometry than central corneal thickness. In addition, there are new applications being developed in glaucoma, because we know that biomechanics are involved in the development and progression of glaucoma, and we would like to characterize that. The Corvis ST has really taken corneal biomechanics from a scientific curiosity from work done in the lab really into the clinic as an important tool for the clinician.
The focal reduction of corneal biomechanical properties has been shown to be the first hit for the development of keratoconus. Basing on this idea, we developed the Corvis Biomechanical Index that has been shown to be highly sensitive and specific to detect keratoconus and also very early forms of ectasia, and has been validated in international studies.
So we have also the new TBI that is coming with a new algorithm based on artificial intelligence in a larger database. They could have optimized the function to improve accuracy, not only sensitivity but also specificity, and that's been very excited because we need artificial intelligence to help us use the data from the overwhelming amount of information that we have from the clinical studies that we do with tomography, biomechanics, and that's going to help us tremendously to improve our care for the patients.
CBI LVC is a new Oculus Index able to screen patients who will develop ectasia after laser refractive correction, vision correction, from patients who will remain stable. Why is this so important? Because you can use in three main places. The first is to screen patients who will develop ectasia immediately after the treatment, so to be able to cross-linking them immediately after, before they develop myopia and all the later complications. The second is when you have to retreat the patient, you should know before if it's a stable cornea or if it's already is at risk, and any additional ablation can be compromising the stability. And the third is when you face regression, you should understand if the regression comes from a weakening of the cornea or coming from regression of epithelial hyperplasia or whatever.
Our study with the Corvis started with a numerical analysis to produce algorithms that can produce biomechanically corrected intraocular pressure readings and also estimates of material stiffness of corneal tissue. These algorithms have been validated experimentally in our lab on ex vivo human eyes, and then they were assessed clinically using clinical data sets obtained from several clinical centers around the world.
So the SSI, the stress strain index, was a measure developed to fill this gap between the indirect measures from the corneal deformation to the direct mechanical measures, where we can actually see the stiffening of the cornea. It has best clinical applications where we can actually see the stiffening and the effect of the cornea when you have like a cross-linking procedure. Instead of just waiting and see if the patient will progress or not, we can actually have an actual measure to evaluate these patients.